Assalamualaikum warahmatullahi taala wabarakatuh. Okay, baik. So welcome back to class of operation research. Alright. So for this video, actually for the chapter three. Sorry, chapter three. Chapter three is linear programming. So what is linear programming? Actually, linear programming is what we want to do is we want to compare between two variables. For this subject, we cover only two variables. We want to compare between two variables x and y. Alright, so for example, in some of the industry, they are in a single machine, they are running two product. Okay, so when they are running two product, so product A and product B, so the question is how many product A and how many product B for them to get the maximum profit or to get the minimum profit. So for this chapter, actually, we want to do the analysis. What is the proportion of the product A and product B, or in the graph? Actually, we use x1 and x2. All right. So this chapter only cover for the two variable. Okay. So, linear programming is a mathematical method determining the way of achieve the best outcome. So, what is mean the best outcome? Best outcome consists of maximum or minimum. Okay, so when we are talking about the profit, is about the maximum, and we are talking about the cost is a minimum. Alright. So for this model, for this linear programming, we only have two model, which is a model maximise model or minimise model. Alright. So in a given mathematical model, some this requirement represented as a linear equation. So that's mean in some of the situation, what we need to do, we want to convert the situation into the mathematical model. Okay, so linear programming can be applied anywhere in the field of study. So not only in manufacturing, we can apply anywhere. So in the business, economy, in also utilized for the some engineering problem. Alright, so industry that are using the linear programming method including transportation, energy, telecommunication, manufacturing. Okay, so this is for them to study to get the maximum or minimum. Maximum is a profit, minimum is a lower cost. Okay, as I mentioned, we have a two model, which is the model of maximization or the model of the minimization. Okay, so for this the video lecture, actually what I want to do is I share with you two situations, which is maximization and minimization. Okay, so for example, this is one of the example for the maximization. So a delivery store make a necklace and bracelet from the gold and platinum. This is the one of the problem, right? So a delivery store make a necklace and bracelet from the gold and platinum. So the store has 18 ounce of the gold, 20 ounce of the platinum. So each necklace required 3 ounce of gold and 2 ounce of the platinum, where each bracelet required 2 ounce of gold and 4 ounces of the platinum. Okay, the demand from the bracelet not more than 4. Okay, alright. So the a necklace earn 300 RM 300 profit, and bracelet is a 400 profit each one. Okay, so the store want to determine the number of necklace and bracelet to make the order to maximize the profit. So use this problem by using graphical analysis. Okay, so this is the situation actually. So how we want to convert into the linear programming? Alright. So from the situation, what we can summarize here is number one, they have two product. The store have two product, where is necklace and bracelet. Alright, so in the linear programming, we for the x-axis we are using we assign as a s1, and y-axis is s2. Alright, so necklace, they have the company, they have two product, necklace and bracelet. Alright, so S1 is a necklace, bracelet is a S2. So actually if you change S1 is a bracelet and S2 is a necklace, also no problem. Alright, so we have defined they have two product, S1 and S2. Okay, so from the gold and platinum, that means they have a two material mixing material to fabricate or to produce a necklace and bracelet, platinum and gold. Okay, so the store has a 18 ounce of the gold and 20 ounce of the platinum. So in the inventory actually what they have limitation of the resource, limitation of the raw material. Okay, which is they only have 80 ounces of the gold, 20 ounces of the platinum. Alright, so necklace S1. So S1 the necklace required 3 ounce of the gold and 2 ounce of the platinum. Okay, for the necklace. So bracelet required 2 ounce of the gold and 4 ounce of the platinum. Okay. Okay, the demand from the bracelet not more than 4. Alright, so what's mean what's meaning here? So if let's say customer place the order, bracelet cannot more than 4. Okay, so the necklace profit 300 and bracelet profit 400. So this is what the information we can get from the situation. Okay. Alright, so now what we can summarize here is a S1 is a necklace, S2 is a bracelet. Okay, so resource available, and we have a three constraint. The first one is the material number one, which is gold, and material number two is ounce. Okay, so if available resource is for the gold we have 18 ounces maximum, and platinum we have 20 ounces of the raw material. Alright, so gold for the S1 require 3 ounces and 2 ounces of for the bracelet for the gold, platinum 2 ounces of the for the necklace and 4 ounces for the bracelet. Okay, so the demand from the bracelet is a maximum 4, not more than 4 here. Bracelet not more than 4. Okay, profit 300 for the bracelet and 400 for the 300 for the necklace and 400 for the bracelet. Okay, now solve the problem. Okay, so the first step is what we need to do. We need to formulate the linear programming. Okay, from the situation here, maximization. So why maximization? For the model of maximize and minimize, we just change the wording here, maximize. Why maximize? Because of the profit here. Okay, the profit we use a maximize, cost we use minimize. Okay, so maximize Z equal to 300 x1 plus 400 x2. Okay, why how I get this? This is from the profit 300 and 400, and subject to, that means here is the constraint. Okay, what is the constraint? 3s1 plus 2s2 less or equal than 18. How I get this one? So 3s1 plus 2s2 less than 18. Okay, 2s1 plus 4s2 less than 20 here, and s2 must be less or equal than 4. Okay, and the last one is s1 and s2 must be more than 0. So why I put it here, s1 and s2 more than 4.0, more than 0, because we only doing the analysis in the first quadrant here. So that means here is S1, here is S2. Our analysis only focus in the first quadrant. Okay, so the other important thing here is the less than here, the symbol here. So since the material is maximum is 18 and 20, so must be less or equal. Okay, now we need to solve the problem. Okay, so we go uh, constraint by constraint. Okay, 3s1 plus 2s2. If we assume s1 s2 is 0, s1 is 6, assume s1 is 0, s2 is 9. So the first point is 9, 6 and 9. So second point is second formula is 2s1 plus 4s2 less than 20. So s1 and s2 is 10 and 5. Then s2 is less than 4. So the point is 0 and 4. Alright, so now we plot the graph. So since from the maximum number here is 10, so we use our graph until up to the 10. Okay, so the first line is so 3s1 plus 2s2 less than 18, 2s1 plus 4s2 less than 20, and s1 and s2 is less than 4. So the all equation is less than or equal. So that's mean where is the shaded area. Alright, so the shaded area is here. Why? This is less. If let's say more, the shaded area is here. This is the shaded area for the less or equal. Alright, so that means from the point here, we call it the shaded area, we call it feasible area. We have four possible point of the answer. So this is number 1, number 2, number 3, and number 4. Alright, so how we want to solve the problem? From the objective maximize z 300 s1 plus 400 s2, we assume z any number. If let's say we assume 1200 and insert into the formula, we get the s1 and s2 is 3 and 4. Okay, so we draw one line for the 3 and 4. Okay, so since this is the maximum solution, so we must move the point into the positive value and find the last point of the z value. Okay, how we want to draw the last point? Draw the 90 degree of the line and move the line into move forward the line, and the last point is here. So 4 and 3. So that's mean maximize z. The answer for the maximum for this situation is 4 and 4 s1 and 3 s2 for the optimum point. So this answer we insert into the maximize problem. Okay, so 3 and 4. So our answer to get the maximum profit must be used at 3 s1. What is s1? Necklace. 4 s2, which is bracelet. Okay, which is the maximum profit is 2400. Okay, alright, understand. Now you can try the others exercise in the lecture note. Okay, so this is for the maximization problem of the linear programming. Thank you very much. See you again, and on the next slide, and then on the next subchapter of the linear programming, which is minimization problem. Alright, so assalamualaikum warahmatullahi taala wabarakatuh.